Now, I want you to take a look at this question very, very well, because this is a question that you have to use your head to think to solve it. All right. Now, look at it very well. The seed is steel bar 6 meter long with a rectangular cross section of 5.0 centimeter times 2.5 centimeters, support a mass of 2000 kg. How much is the bar stretched? Given Young modulus of elasticity of steel to be 20 times 10 raised to the power of 10 Newton per meter square. This is a very critical question, and you have to use your brain to solve it, okay? That's what physics is all about. It wants you to think and find solutions to problems. Now, how do you solve a question of this nature? So, the first important thing I tell students is that you have to write the data that you have been given from the question so that you know what you are supposed to find. Is that clear? Now, let's also write all the data that you have been given from this question, and then we can know also what we are asked to find. Now, the question is actually asking us to find the, it says, how much is the bar stretch? So, it's just, this is a question on hooks that involve the Young modulus. So now what they are asked to find is the extension. But first thing, as I said, let us write the data that we have in this question. Alright, so first let me write solution. Now, from the question, we have that the bar is 6 meters long, so that means the length is 6.0 meters. That is the length of this bar. Then another information that we have been given from this question is, you see, the bar is rectangular in nature, and it has a cross section of 5.0 times 2.5. Now, when you are talking about a rectangular something, the area of a rectangle is what? Length times breadth. Is that so? From this information you have given, you know that this is the area of this bar. That means this is the length and this is the breadth. So the area A is 5.0 times what? 2.5. So if you multiply 5.0 times 2.5, the answer will give you 12.5 centimeter. Remember, it is in centimeter. So because you multiply it, is going to be centimeter square. Because look at it, we have centimeter here, we have centimeter. Centimeter times centimeter will give you centimeter square. That's the unit for area of a rectangle. Now, again, you have to be very careful from here, because this unit is in centimeters. And remember, standard unit, in standard unit is meters. So we have to find a way of converting these centimeters to meters. Remember, 100 centimeters equals to 1 meter. So if we are converting this thing, we are going to divide it by 100. If you are converting centimeters to meter, you divide it by 100. But this is centimeter cube. Alright? So that means this thing you are not just dividing by 100 centimeters, but 100 2 times 100 times 100. Because first we have 5 centimeters. So you are dividing it by 100. This one also you are dividing it by 100. So what I'm just trying to say is this. So we have 100 centimeter times another 100. Because this is centimeter square, that means the 100 is supposed to be 2 times. That's why we have this. Is that clear? So if we divide 12.5 centimeter by this, remember 100 times 100 will give us 10,000. So we are dividing 2.5 divided by 10,000. And if you do that, you realize that you are going to get 0.00125 meters. So this is the answer you are going to get. But because this is in decimal, this is in the zeros, I want to write it in standard form. You remember your math, right? I want to write it in standard form. So I'll move this decimal point up to 4 places. I'll move it 1, 2, 3, 4. So I'll put my decimal. So that means if I'm writing this now, it will be 12.5 times 10 raised to the power of, how many places did I move? 1, 2, 3, 4. So I'll take minus 10 to the power of 4. So this is in meter. This is, I'm writing this now in standard form. Hope you understand, right? Now we have converted this to meters. So we have converted it to standard form. That's for this one. So I'm just going to clean this one because this is the main thing that I need. So my area is given as 12.5. So I'll have to clean this one. So if you multiply this, we have the answer we got is 12.5 times 10 to the power of minus 4 meters. Okay. Alright, now we have our area. The next thing we need, the next information we are given is that the mass of what this pillar is supporting is 2000 kg. So that means our M is 2000 kg. Okay? And then we are given that the Young modulus of elasticity is 20 times 10 to the power of 10. So that means Young modulus is used, sometimes it was given as y. Some textbook give it, represent it with y. Other textbook usually represent it with letter e, like this. So we are going to use e here. So the young modulus is given as what? 10 times 20 times 10 to the power of 10 Newton per meter square. Now we have drafted out the data that we have been asked to find. So what the question is asking us to find the extension. They say how is the bar story. So this is what we need. We are looking for extension. So now we have to write the formula for the Young modulus. How is the Young modulus? What is the formula? The formula for the Young modulus is given as E is equals to F, that is force all over area divided by the extension divided by the length. So this is the formula for the Young modulus. Now what we asked to find is this E. So that means we have to find a way of making this E subject of the formula. We are going back to math. That's why maths and physics are always connected. You have to know your maths very well so that you can be able to apply it when you are solving physics questions of this nature. Now from this question you can see that we are asked to find extension. So we have to make this one subject to the formula, alright? So if we want to make this one subject to the formula, remember, let me just do a small explanation of how you can make this one subject to the formula here. Now we have E. This is the same thing. I can write this thing as E, which is force all over area divided by E all over L. This is what actually this thing means. It's just this division that I put it in this form, okay? So according to math, I can write this thing as F all over A. If I change this thing to multiplication, this division, that means this one now is going to go up while this one is going to come down. So my L will go up and my E will come down. Do you understand? Because I've changed it to multiplication. So the one that is down will go up while the one that is up will come down. So if I multiply it now, that means my E is equals to F times L all over A times E. Are we together? Now what I want to make sure the formula is this E. So to make this E, I'm going to cross multiply. Remember this is like all over 1. So that means this is multiplying this while this is multiplying this. So I'm going to have that this multiplied by this now will be E A E is equals to 1 times this is still F L. So if I want to make this E sorted formula, I'm going to divide both sides by E, capital E and A. I also divide this side by capital E and A. Now why am I dividing? So that this E and A will cancel this E and A. So what will remain here is only this, on this side is only this E. So that means my E is going to be this FL all over EA. So you can see now from the Young modulus, I have succeeded in making E my subject of the formula. Is that clear? So since I have made E subject formula, I can now substitute all my parameters and find out what is my extension from the question we asked to find. So what is force? Again, you can see that we have not been given force from this question, but from the data you have been given, you should be able to know what is your force. That's why physics wants you to think. Now remember, if you can remember force, the formula for force is given as let's write it here, F is equals to mass times acceleration due to gravity. Is that not? This is the formula for force. So what is mass? Remember, you are giving mass of 2000 kg. So that means my F will be 2000 multiplied by G. You know what is G? G is acceleration due to gravity, and it's a constant. The unit is 9.8. That's the value of acceleration due to gravity. So this is our force. Okay, so we can now substitute it into this formula. Since you know what is force, substitute and find the value of E. So that means my E will be equals to what is force? This is what I got as force, which is 2000 times 9.8. So the next thing is times this L. What is the value of L? Look at it. Our length is 6 meters. So you see times 6 all over, what is my E? I've already been doing my Young modulus, which is what? 20 times 10 to the power of 10. Okay? Times my A. What is my area? My area is what? 12.5 times 10 to the power of minus 4. So, using your calculator, if I multiply 2000 kg times 9.8 times 6 divided by 20 times 10 to the power of 10 times 12.5 times 10 to the power of 4, my answer is going to be 4.7 times 10 to the power of minus 4 So, and the unit of extension, that is, extension is length now, so the unit is meters. So, this is our final answer. This is the extension that we have been asked to find from this question. Hope you understand.